These are the hello packet content. When I enable OSPF on R1 and R2, the router ID what I'm going to have is going to be unique router ID. That's why I wrote here unique. Area type, which is also been shared in hello packet of OSPF, it has to be same. If you are configuring this end as stub area, make sure it is also stub. If it is NSSA, it is also NSSA. Area ID has to be same. Meaning, if this interface is part of area 0, this should also be part of area 0. It cannot be area 1 and all. If you are configured as area 1, in that case, OSPF neighborship will not be formed. Subnet mask has to be same. If this send I am configuring 255.0.0.0, this would also it should be 255.0.0.0. If you are having different subnet mask, then also there will be a problem. Hello timer and dead interval has to be same. You can also change hello timer and dead interval. MTU should also be same. By default, MTU, which is maximum transmission unit, is 1500 bytes. 1500 bytes. Network type, which is like 4 network types we have in OSPF. One is broadcast, point to point, point to multi-point, and non-broadcast multi-access. If this end I'm configuring it as point to point, neighbor should also be point to point. If it is NBMA, the neighbor should also be NBMA. Okay. So let's talk about these one by one in the configuration. Let me load my GNS3. Yeah, in the meantime, we can talk about something else. So we can talk about the OSPF hello states. Now, as I said, OSPF, once you enable an R1 and R2, they try to form full neighborship. The full neighborship is officially termed as adjacency. Okay. When you see full in the output of show IP OSPF neighbor, it means the neighbor, R2 is fully adjacent with R1. Okay. Initially, when I enable, 1 minute. So imagine that I have R1, I have R2. When I'm enabling OSPF on R1, R1 will be sending out hello packets every 10 seconds. One will be sending out. And R2, I haven't enabled OSPF. In that case, he will not receive hello packets. He will be termed as downstate. Okay. So once I enable OSPF on R1, once I enable on OSPF on R1 and even R2, if I don't enable, R1 will be sending out hello packets, but it will not receive any hello packets. R1 considered to be in downstate. Now second is init state. Now when enable OSPF on R2, R2 will start sending hello packets. R1 receives hello packets. Now R1 is sending as well as receiving hello packets. R1 is said to be in init state, initialization state. Now two-way. So in two-way means when R1 is receiving a hello packet and it sees its own router ID in the neighbor's hello. For example, initially imagine that this is one guy. Okay, wow. He is one guy, his name is R1. Second guy, his name is R2. Initially, when they meet for the first time, R1, R2, both of them will say hello, hello, like as a normal human being. Then immediately you'll say, hello, my name is this. Then after they know each other in two-way state, R2 will say hi R1. Right. Similar to that, R1 will say hello R2. So when R2 says hello R2, R1 is keeping R2's name in it. Similar to that, in two-way state, R1 will receive hello packet from R2 with its own router ID in it. So when I see my own router ID in the neighbor's hello, I'll go into two-way state. That is called two-way state. Attempt we'll talk about later because it comes only at non-broadcast multi-access network, not as of now. We are discussing about normal broadcast network. Broadcast network is default. By default, when I'm going to use Ethernet cable, that is considered to be a broadcast network. Then we have Xstart. See, as I told, OSPF exchanges what? LSAs, link state advertisement. Now, once they know each other, they have to go through an election process on who will exchange the LSA first. Is it going to be R1 who will be sending the LSA first, or R2? So based on the priority and based on the highest router ID, one guy will become master, a second guy will become slave. This selection happens in XStart state. In XStart state, we also compare the MTU value. So in OSPF, MTU has to be same. If MTU is different between R1 and R2, in that case, it will stuck in XStart state. Now, why there is a restriction on this? Why do I need MTUs to be same? The reason is OSPF does not support fragmentation. If MTU is different, in that case, there may be a chance that R2 need to fragment its packet, means break the packet before sending it to R1. So because OSPF by default does not support fragmentation, MTU has to be same. If it is not same, it will stuck in XStart state. And there is one small condition also. My MTU, for me to go into exchange state, for me to cross XStart state, my MTU should be greater than or equal to neighbor MTU. Neighbor MTU. Imagine that R1 is MTU is 1500. This guy MTU is 1600. MTU is an interface specific information. It's not for routers. It's for interface. Imagine that interface FA0/0 MTU is 1500. Here interface FA0/1 MTU is 1600. In this condition, R2 will go into exchange state, but R1 will be in XStart state. Why it went to exchange state? See the condition. Because my MTU is greater than equal to neighbor's MTU. These specifications are not there in normal books. Okay, I'm just giving you based on my experience. Now this is the one point about XStart state. Now what happens in exchange state? In exchange state, we normally do window shopping. Window shopping means R1 gives what are the LSAs I have. It just shows it to R2. Exchange doesn't mean that you're exchanging database. R1 is showing, see, these are the IPs what I have reachability to. It shows it to R2. Similar to that, R2 shows to R1. Now they're not exchanging any information. They're not updating information. They're just exchanging and seeing. Now whatever R1 is missing about R2's information and whatever R2 is missing in its order table, what R1 has shared, they will update in loading state. In loading state is what your update happens, or finally exchanging of LSA happens. It does not happens in exchange state. A lot of people misconception that is there, that exchange happens in exchange state. Nothing like that. Again, exchange is like a window shopping, just showing. It's not exchanging. In loading is what we are actually exchanging the LSA. Full means fully synchronized state. So whenever R1 and R2 has found fully adjacencies, it will be in full state. If someone says that, hey, R2 is a neighbor for R1, but R2 is not fully adjacent, that means it is there in two-way state. I'll tell you one thing. Imagine that you have R1, I have R2, I have R3, I have R4. This guy is DR, this guy is BDR. When I go here, when I check show IP OSPF neighbor, with R1 it will show full/DR. With R2 it's going to show full/BDR. With R3 it will show two-way, because both these routers are termed as DR other routers. DR other routers do not form full adjacencies. Think about the story when I talked about the DR, the reason why we need DR, to avoid unwanted sending and receiving of LSAs, right? So because I don't want any direct exchange of LSAs to this guy who is a DR other router, because I want exchange of LSA only with this guy, DR routers, or else if it fails, BDR routers. That's the reason between DR other and DR other, you'll end up seeing two-way state. You will not see full state. Do not think there is an issue in the network. Two-way is also a fully working condition. Two-way, if you see two-way, which means neighbor, he is my neighbor. If you see full, it is he is my adjacent router. So there's a difference between adjacency and neighborship. Neighborship is not equal to adjacencies. Okay, wow. This is the third point, I think. One more point we have about the down and init state. I think listen carefully. When I have R1, when enabled OSPF on R1, I'll be start sending hello packets, right? I'll be considered to be in down state. He's receiving hello packet, but he don't know what is that packet it means, because I haven't enabled OSPF on R2, right? If you don't enable OSPF on R2, for R2, that packet is an alien packet. I don't know what to do with that packet because OSPF is not then configured in my router. He's receiving the hello packet, but it is not processing it. It's simply dropping it. He will be in down state. Now once I enable OSPF, right, will it be in down state initially? It won't be in down state, because instantly when you enable OSPF, he receives the hello packet, instantly will go into initializing state. So you'll always see when you enable OSPF, right, one end will be down state, other guy will directly go into initializing state. This you will not notice actually when you do lab and all, but when I did in CCI lab and all, we have noticed in this packet capture tool and all, we have clearly noticed that one guy will be in down state, other guy will directly go into initializing state. That is the reason behind it. Okay, fine. These are the 8 states of OSPF, out of the which one state is for only NBMA network. Now, what is NBMA network? We discussed about this yesterday. We discussed about NBMA network, where I told we have to manually configure the neighbors. So when I say you have to manually configure the neighbor, which means there will be an attempt to form neighborship. So because in non-broadcast multi-access network, the multicast packet and broadcast is not allowed. In that case, I cannot identify my neighbor. Normally, to identify neighbor, I'll be sending out hello packet site to 224.0.0.5 IP address. Because in this network, if I enable this network to be NBMA network, my multicast is not allowed, because of which I cannot form neighborship with that guy. So you have to manually configure who is your neighbor. You have to go inside router OSPF, AS number, and process ID, then neighbor IP. If you give neighbor IP, then they will send unicast packet to form neighborship. Okay. Right on this point, then we'll do the lab one by one. Now what we're going to do, we'll try to apply one by one rule, whatever said here. So as I said, I should have unique router ID. These are the parameters which has to be matched for an OSPF to come up, OSPF neighborship to come up, like unique router ID, same area type, same area ID, same subnet mask, hello interval same, MTU same, arrow type also same. So let's configure them one by one. I'll take the console. Here it is. I have already configured OSPF, if I'm not wrong. Let me verify it. Show IP OSPF neighbor. The neighbor is full /dr. Show IP OSPF neighbor. It has 2 neighborship. So ultimately even R3 has a neighborship with R2. Okay. So let's try to change one by one. As I said, I should have a unique router ID. So how do I change router ID? Go to router OSPF 10. Hey, 1 minute. Router OSPF gets process ID. Yeah. Router OSPF 10. Then change router ID. What if I'm going to keep it as 2.2.2.2? This router ID is of R2's router ID. This number. The router ID once you change, it will not change immediately, because router ID election is a non-preemptive. Non-preemptive means immediately it won't change. First time when you are configuring OSPF, it will elect one router ID. But if you're going to change the router ID when the OSPF is up and running, it will not change immediately. So you have to clear the OSPF process. The command to clear OSPF process, it is showing there itself. Clear IP OSPF process and say yes. Now OSPF connection will turn down. Again, we'll try to form neighborship. And meanwhile, when I try to form neighborship, I will identify that duplicate router ID has been configured to neighbor. So it says that, hey, I think there is a duplicate router ID between me and my neighbor, because of which I'm unable to form OSPF neighborship. It says OSPF detected duplicate router ID of 4 times 2 from 12.002. This log even tells you from whom am I getting the issue. Imagine that R1 has 10 more neighbors. So R1 has like 10 more routers like this, a lot of routers. So in that case, if you don't get the information from which router am I getting duplicate ID issue, we cannot fix the problem. So thinking this in mind, even the log tells you because of whom am I getting duplicate router ID. So let us check the neighborship. Show IP OSPF neighbor. Neighbors in downstate. If OSPF neighbor shows nothing with a space, which means it is in downstate, you will not see neighbor IP and state as down. Other state will be visible, like init will be visible, init, extart, exchange, loading, full, everything will be, you can see. Even two-way you can see. We cannot see it down. Okay. So let me fix the problem. So I'll just go into router OSPF 10. I'll configure a router ID as different guy. Router ID 1.1.1.1 and clear IP OSPF process. Sorry, clear IP OSPF process. I think they already formed neighborship. Show IP OSPF neighbor. So now we are back into picture. So as you can see here, if I use same router ID, the OSPF getting broke. Secondly, your area type, area ID. By default, area type is normal. What if I want to configure area type as stub area this side? So let me configure it as stub area. So as per the PPT, your area ID has to be same. It can be different. So the neighbor end, this guy is normal area. What if I configure my end as stub area? Again, OSPF will break the connection. Let us configure router OSPF 10 area 0 stub. That's all. It says backbone area. Yeah, I'm sorry. We cannot configure the backbone area as a stub area. The backbone area should always be the normal area. We cannot configure area 0 as a stub area or NSSA or totally NSSA and all. It's not possible. So let me do that lab in between R3 and R5. They are part of area 2. Right? In that case, yes, we can configure area 2 as stub area. So let me just open R5. In the meantime, I'll configure R3's area 2 side as stub area. Let's do that. Let's go to R3. Yes, R5 came up. R3. Configure terminal, router OSPF 10, area 2 stub. That's it. This is a command to configure the area 2 as stub area. Area 2 stub. Go inside the router OSPF mode and type area 2 stub. Let's do the same in R5 also. Now R5 is a normal area. R5, according to R5, FA0/1 or the area what I've configured is normal area. Area 2 is. Here we have made it as stub area. Now what will happen for OSPF neighborship? Now it says down/dr other with 5.5.5.5, which is my R5. I see that it is down/dr other. It says the state is down because of what? Because of area type mismatch. I said it has to be same. Now to fix the problem, I can configure R5 area 2 as stub. Both of them will become stub now. Router OSPF 10 area 2 stub. Now the neighborship should come up now. Show IP OSPF neighbor. That's in start state. Now they went to full state now. We're going to try it. This is the second one. Third is what? Area ID. Area ID means if this center is area 2, this center should also be area 2. If I configure it as area 1, then also it cannot form neighborship. Now can I make this as area 1? Just go inside the network 35.0.0.0.255.255.255 area, made as 1. This side I'm making it as area 1, neighborhood is area 2. In that case, what will happen? Let me clear the process, clear IP OSPF process. Yes. This, because of the area mismatch, it should go to downstate. Show IP OSPF neighbor. I have no clue why it doesn't went to downstate. This end is what? Area 1, right? Let me verify it. Show IP OSPF interface FA0/1. Show IP OSPF. I'm having area 1. Okay, it also has something called area 2, because of which it is being enabled. Let me just check the configuration. 1 minute. Include area. Okay, this configuration is still there. Let me just remove it. Configure terminal router OSPF 10. No. That's it. Now it went down because of area mismatch. Show IP OSPF neighbor. It's in downstate. So area ID should be same. Router OSPF 10 network 35.0.0.0.255.255.255 area 2. It should come up. Yeah. Show IP OSPF neighbor. It came up now, right? This is also done. Then hello interval. This has to be same. By default, hello it is 10 and 40 seconds. It's 10 and 40 seconds in broadcast and point-to-point network. If it's going to be point-to multi-point, or if it's going to be a broadcast, point-to multi-point and non-broadcast multi-access, in that case, hello is 30 seconds, dead is 120 seconds, 4 times hello. Dead interval is 120 seconds. Okay, so I think this you can also. Now, can I change the hello timers and all? For that, I have to go inside interface. So it is interface FA0/1. I'll say IP OSPF hello interval. I can give any value 10, 20, 30, but make sure it is same. Then IP OSPF dead interval. Give anything. Make sure it is 4 times the hello always. That's recommended one. This is the command I configured here. I just changed the ID, and this is the command.